Good afternoon, class. We are looking at Chapter 8, Further Application of Trigonometric Functions, Section 8.4, Polar Coordinates, Equations, and Graphs. The objectives of this Section 8.4, Polar Coordinates, Equations, and Graphs. Identify and graph polar equations by converting to rectangular equations. Test polar equations for symmetry. Graph polar equations by plotting points. So a unit circle, a point has coordinates x comma y, x squared plus y squared equals 1, and x represents cosine, y represents sine, tangent is y over x, and the rest of them are reciprocals. We can follow them. Every trigonometric function is an odd function, except cosine and therefore secant, which means f of minus x equals f of x in those cases. Fundamental identities, such as Pythagorean identities, quotient identities, reciprocal identities, a right triangle, a squared plus b squared is c squared, a plus b must be 90 degrees. Sine law indicates sine a over a, sine b over b, and sine c over c are equal in a triangle. And cosine law says a squared equals b squared plus c squared minus 2bc cosine a. If you move this around and so forth, you can find cosine a as b squared plus c squared minus a squared over 2bc. And reminding you that circles centered at 0, 0, x squared plus y squared equals r squared. That's the equation of a circle. Centered at h comma k, x minus h quantity squared plus y minus k quantity squared equals r squared. Polar coordinates. In a two-dimensional coordinate system, each point on a plane is determined by either a rectangular format x comma y, a distance from y and x-axis. So you have the grid x comma y, or polar r comma theta, a distance from a reference point called the pole, the origin or the pole. If we put the two grids together, the origin or the pole, and the polar axis is along the positive x-axis. So r comma theta, a distance from a reference point called a pole, and an angle from a reference direction called the polar axis. So this is x, this is y, and this distance OP is r, and this is angle theta. Therefore, we have the following situation. Rectangular x comma y, polar r comma theta, x squared plus y squared is r squared, tan theta is y over x. You must adjust for the quadrant, and I can't emphasize this enough. Polar has coordinates r comma theta, rectangular has coordinates x comma y, and x is r cosine theta, y is r sine theta. That's how we write them. Polar, which has coordinates r comma theta, can be represented infinitely many times in the following manner. R repeats, then theta you can add 2k pi where k is an integer. If you want r to be negative, then you add odd multiples of pi, which means add pi plus 2k pi. Again, k is an integer. Now, polar equations and graphs, rectangular and polar grid. So if you look at the rectangular grid, it's obvious you have x and y axis. So for example, 1 comma 2, 1 to the right, 2 up, negative 3 comma 1, negative 3, that means 3 to the left, 1 means 1 up. You can locate that. When it comes to a polar grid, you really have to have circles, okay, concentric circles, and then we have radius 1, 2, 3, and so on and so forth. For example, if you want 2 comma pi over 4, If this is the first one, this is the second circle. So anywhere on the circle, the distance is 2. So you locate pi over 4 first, and you go 2 tick marks. That means the second circle. 4, 5 pi over 4, you locate 5 pi over 4, and you go 4 tick marks or the fourth circle. That's how you come up with a point. And it's important to notice a polar equation of a curve is the one expressed in polar coordinates and written with r as a function of theta. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. These equations may demonstrate different forms of symmetry around the axis. Also, pole, which has coordinates r comma theta, if r is 0, so distance is 0, theta can be any number. Okay, theta can be any number if r is 0. So that's pretty straightforward, everybody. Here's an example we're going to start with. We want to identify identifying and graphing polar equations. So we want to identify and graph the equation r equals 3, and we want to convert it to rectangular equation, reminding everybody x is r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, tan theta equals y over x. So that will help us remember what we want to do. R is 3 regardless of theta. Well, one easy way is to square both sides. R squared is 3 squared or 9. R squared, you know it to be x squared plus y squared. And that represents a circle centered at 0, 0 with the radius 3. So R is 3, x squared plus y squared equals 9. Circle, reminding you that circles have the equation x squared plus y squared equals r squared, centered at 0, 0, and that's the case. Or if it's centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. Therefore, we are looking at a circle which is centered at the origin or the pole, and r equals 3. So basically the third one. If you go with circle number 1, circle number 2, circle number 3. So that's the center, and that's the circle. So r equals a number, r equals a constant, represents a circle centered at the pole or the 0, 0. Theta equals pi over 4. Identify and graph the equation. Convert to a rectangular equation, and we remember that tan of theta equals y over x. So we can take the tangent of both sides. So if theta is pi over 4, tan of theta is tan of pi over 4. We know tan of pi over 4 is 1, and tan theta is y over x. So we're going to replace this with y over x. And this one with 1. And cross product gives you y equals x. As you know, y equals x is a line that goes through the origin. So when theta is pi over 4 in polar format, or y equals x in rectangular format, and in general, y becomes tan of theta times x. So y equals x. So at pi over 4, you draw a line, and a line that goes through the origin. any line that goes through the origin is tan of some angle theta times xy equals tan theta times x. So any line through the origin has this equation, this type of equation. All right, what about r sine theta equals 2? We want to convert it to rectangular equation. Well, y equals r sine theta. Therefore, I can replace the r sine theta with y and write y equals 2. So y equals 2. That's why we have this also in essence rectangular grid. So the line y equals 2. So the first and the second segment right here, this is the point and you draw it. So it's a horizontal line, this point, and draw this, which means horizontal lines in polar format have the form r sine theta equals some number. This is a constant. This is a number, everybody. We want to identify and graph this equation. R cosine theta equals -3. So we want to convert it to a rectangular equation. We go back down here and we look and we see x equals r cosine theta. Therefore, r cosine theta represents x. We get x equals -3. R cosine theta is -3. X must be -3. X equals -3 is a vertical line. So the first one, the second one, the third circle has a distance of 3 from the origin. So here, and you draw that. So this is the point. You draw that. And that means r cosine theta equals a constant equals a number gives rise to a vertical line of the equation x equals a. X equals a. So that's pretty straightforward, everybody. What about this one? Identify and graph the equation r equals 4 sine theta converted to rectangular equation. And to do so, I hope you remember the trick that was discussed last time. Multiply both sides by r. When you have r on one side and on the other side, you have something with sine or cosine, the technique or the trick is to multiply by r. So this becomes r squared, this becomes 4 r sine theta. Of course, r squared equals x squared plus y squared. 4 r sine theta is y. So 4 y. Now we're going to bring the 4y next to y squared. And by completing this square, we get to the answer. So first and foremost, move the 4y. This is fine. This one, b is -4 divided by 2 is -2. Square it becomes +4. Let's add +4 to both sides. Again, this is x squared, this is y, and whatever b over 2 is -2, y -2, quantity squared. Now, this is a circle. So when r is 4 sine theta, we get x squared plus y -2 quantity squared equals 4. So r equals 4 sine theta is a circle centered at 0, +2, x minus h quantity squared plus y minus k quantity squared equals r squared, centered at hk, centered at 0, 2, along the positive side of the y-axis, or in the, as far as the angle is concerned, pi over 2. And with the radius being square root of 4 or 2. So we are looking at a circle centered at 0, -2. Radius is square root of 4. Square root of 4. We are comparing these two, okay? So 0, 2, and again, one circle to the second one, okay? And then you draw a circle because this is 4 and the radius is 2, so it goes through the pole, okay? So what does it mean? If we have r equals a number times a sine, it results in a circle along the y-axis. Now, where is the center? Well, depends on this one, okay? In this case, when it's 4, you cut it in half, becomes 2, 0, 2. All right, we continue with more examples. Identify and graph the equation of r equals -2 cosine theta, convert to rectangular equation. And as I've mentioned, when we have r on one side, sine and cosine, any of them on the other, the trick is to multiply both sides by r. So we are going to multiply both sides by r. And the reason is because this becomes r squared, we have the answer, x squared plus y squared. And this, whether it involves sine or cosine, when we also have r, it becomes x or y. So let's multiply by r. We get r squared minus 2r cosine theta. And obviously, the left side, we'll change it to x squared plus y squared minus 2r cosine can be replaced by x. So minus 2 or cosine, that means minus 2x. And again, we are going to move the negative 2x. This time we set negative 2x next to x squared. And this is fine. This one we use completing the square. So we are going to write b is 2 divided by 2 is 1. Squared is still 1. So this becomes x, and whatever b over 2 is, this is 1. That means plus 1. Okay. So first, we are going to add 1 to both sides. X squared plus 2x plus 1. This doesn't change, and this is 1. And this, the variable, whatever it is, it's x, and b over 2 plus 1 quantity squared. The rest doesn't change. Therefore, when we are looking at r equals negative 2 cosine theta, it's the same as x plus 1 quantity squared plus y squared equals 1. Polar format, rectangular format, everybody. As we compare, it becomes a circle centered at negative 1, 0. Radius, square root of 1, happen to be 1. So first, you locate the center, minus 1, 0. I want to make sure we understand that. 0 is this direction, everybody. That means the angle 0. So if I want 1, 0 is here, 2, 0, 3, 0, 4, 0, 4, 5. If I want to go with the negative, I go in the opposite direction. So minus 1 takes me to the opposite direction. So we are still on the first circle, but in the opposite direction right here as the center. Okay. And now when we draw the circle, because the radius is 1, it hits the pole. So it covers the pole. And right away, we recognize that if r is equal to something times cosine, then it gives us a circle such that the center is along the x-axis. In fact, you might see that negative means along the negative side, positive means along the positive side, and half of that would be the radius. So there is a lot of information here. So let's look at the synopsis of what we covered so far. When r equals a number, when r equals a constant, we have a circle. The center is at the origin or pole, and the radius is a. So r equals a is a circle. Theta equals alpha. That represents a line in rectangular form where y is tan of alpha times x. And of course, if it's a common arc, you can figure it out. Horizontal line, HL for short, r sine theta equals a constant, gives rise to the horizontal line y equals. Vertical line, VL for short. R cosine theta equals a constant. A is a number. Then x equals a in rectangular coordinate. X equals A is the equation of a vertical line. So R equals A is a circle, theta equals alpha is a line through the origin. R sine theta equals a number is a horizontal line. R cosine theta equals a number is a vertical line. And now if A is positive, R equals 2A cosine theta is a circle. All of this, if we have some number times cosine or sine, doesn't matter. That results in a circle. But what type of circle? If it involves cosine, then the center is along the x-axis. If it involves sine, this center is along the y-axis. Now, positive 2a, in both cases, cut it in half, and the center becomes a0, in this case becomes 0a. This one minus a0, and this one 0 minus. In all of those cases, the radius is half of this. If it's negative, remember, radius can't be negative, is the absolute value. So one more time. R equals some number times cosine or sine results in a circle. If it involves cosine, the center is along the x-axis, the polar axis, on the right or left. On the right if it's positive, on the left if it's negative. If it involves sine, then it's along the y-axis. If it's positive on the positive side, negative on the negative side. And the radius is half of this number, even if it's negative is the absolute value. So that's a lot of information we just came up with by looking at a few simple examples. Okay, but like I said, you can justify in each case what you have. Symmetry in polar coordinates. You remember that we have the odd and even symmetry in the case of a rectangular coordinate system. Quickly just remind you. I mean, just for the sake of argument, you see the right and the left side is the same, this side and this side. That's even, and it was f of minus x equals f of x. Okay. On the other hand, something like this, y equals x cubed, f of minus x is minus f of x. This is odd symmetry, right? So if you have a point here, you connect it to the origin, and if you go the same distance, you have another point that's symmetric with respect to the origin. This is what we did before. That has got nothing to do with polar, okay? But what happens in polar, let me erase and go over that for you. All right, symmetry with respect to WRT, short with respect to the polar axis, the x-axis. If in the polar equation r comma theta, okay, can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis, the x-axis in essence. So take a look. So theta is pi over 4, for example. We have r comma theta, and over here r comma negative theta. If we result in the same equation, then it's symmetric, point symmetric with respect to the polar axis. Okay. Symmetric with respect to the line theta equals pi over 2. In essence, you can think of it as y-axis on the positive side, of course. If in the polar equation r theta can be replaced by r comma pi minus theta, the graph is symmetric with respect to the line theta equals pi over 2, which is the y-axis. Okay, so this point has coordinates r comma theta, and this one as coordinates pi minus theta. They're, in essence, if you remember the concept of a reference arc, so if you think of theta as a reference arc in the second quadrant, pi minus theta, okay? That gives you the angle. Symmetric WRT with respect to the pole or origin. If in the polar equation, r comma theta can be replaced by negative r comma theta or r comma theta plus pi, the graph is symmetric with respect to the pole. So here's r comma theta, here's minus r comma theta, or r comma theta plus pi. So that's pretty straightforward, everybody. That's the concept of a symmetry. Graphing polar equations by plotting points. Graph r equals 1 minus sine theta, which is a cardioid. It's like a heart. So first of all, class, the way you graph this, just you can plot points. And some of the points, of course, are easy to find. Some of them you might need a calculator, but go with common arcs, common angles. It's very easy to see. But we want to add things we learned here, the concept of a symmetry. It's symmetric with respect to the polar axis if r comma theta can be replaced with r minus theta, with respect to theta equals pi over 2 of the y-axis if r comma theta can be replaced with r comma pi minus theta, and it's symmetric with respect to the pole if we can replace it with negative r comma theta or r comma theta plus pi. So let's look at all those for practice. So we're going to look at the first case. That means we are going to look at r comma theta versus r comma minus theta. And so if you want to check that, you are going to replace the theta with negative theta. And if you get the same function, polar function, then yes, it works. Okay, the test says yes, it's symmetric. As you know, sine of minus theta is, because sine is, every trigonometric function is odd, you remember that, except cosine. So this is negative times negative positive. And is this identical to the original one? Absolutely not. So the test fails, which means the polar equation or function is not symmetric with respect to the polar axis or the x-axis. Let's work with the second case and replace the theta with pi minus theta and work on that. So 1 minus sine of pi minus theta. Now, sine of alpha minus beta, sine alpha, cosine beta, minus cosine alpha, sine beta. That's exactly what we are going to do. So 1 minus the parenthesis. This one is sine pi cosine theta minus cosine pi sine theta. What is sine of pi? 0. What is cosine of pi? Negative 1. So in essence, this goes away, 0. Minus minus becomes plus sine theta. So right here, we get plus sine theta. Minus in front of it makes it negative. So r equals 1 minus sine theta. So we look at this. Is this identical to the original one? Yes. Okay. The graph is symmetric with respect to theta equals pi over 2. It works for that one. Okay. Let me erase my work. So we checked with the first one, it didn't work. With the second one, it did. We're going to work with the last one. So we are going to replace the r with negative r. And to make this into r, we're going to multiply both sides by negative. This becomes positive. This becomes negative. This becomes positive. And obviously, that didn't work. They are not. Are they identical? No. Okay. However, you have to check with this one also. So let's replace the theta with theta plus pi. So r equals 1 minus sine of theta plus pi. Also, we have to check that. So sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, right? I just wrote the sine of alpha minus beta for you. Let me just quickly write this too, but sine of, let's see, where do I want to write that here? Sine of alpha plus beta. Sine alpha cosine beta plus cosine alpha sine beta. Therefore, 1 minus sine theta cosine pi plus cosine theta sine pi. Cosine pi is -1 and sine pi is 0. This goes to 0. This goes to plus sine theta. Check it with the original one. Are they identical? No, it's not symmetric with respect to the pi. Just in case. So it's symmetric with respect to the line theta equals pi over 2 of the y-axis. I'm going to continue graphing. And I'm reminding you the graph is symmetric with respect to theta equals pi over 2, which means if you graph this half, then the other half is easy to see from the symmetry. That's the concept. But the best methodology is to plot points. And so we are going to write theta, r equals 1 minus sine theta, and r comma theta. So notice I've picked all easy and common arcs. So we're going to go over them quickly. 0, sine is 0, we get 1. Pi over 6, sine of pi over 6 is 1/2. We get 1 minus 1/2, which is 1/2. Pi over 4, 1 minus sine of pi over 4, which is square root of 2 over 2. Pi over 3, 1 minus sine of pi over 3, which is square root of 3 over 2. Pi over 2, sine of pi over 2 is what? 1. So 1 minus 1. 5 pi over 6. Now, it's important to know for 5 pi over 6, 7 pi over 6, 11 pi over 6, this is the reference arc. And we know sine of pi over 6 is 1/2. 5 pi over 6 is the same thing because in the second quadrant it's positive. So 1 minus 1/2, we get 1/2. Pi, sine of pi is 0, 1 minus 0. 7 pi over 6. Now, it's the same as pi over 6, but in the third quadrant is negative. So 1/2 makes it negative. 1 minus negative 1/2, that means 1 plus 1/2, that means 3/2. 3 pi over 2, negative 1 with the negative is positive, with 1 becomes 2. 11 pi over 6 in the fourth quadrant, sine is negative, so minus 1/2. With this plus 1/2 is 3/2, and 2 pi is back to 0. So I'm hoping nobody has any problem with those, okay? So let's write the pairs, everybody. Now, r comma theta. So this is 1, 0. This is 1/2 pi over 6, and the rest of it. So let's write those. Let me erase my work class. Now, what I want to do, I want to use the easy ones. For example, 1 minus square root of 2 over 2, I need to, square root of 2 is 1.41, divided by 2 is about 0.7, 1 minus that is 0.3. I don't want to go there. I want to go with the easy one. So I'm going to start with 1, 0, for example. Okay. So, and this may not be to scale, but 1, 0, I always start with theta. That means I'm along the positive side of the x-axis, 1 unit, so there. So you plot that. 1/2 pi over 6. So I locate pi over 6 or 30 degrees. 1/2, this would be 1, so halfway through that, roughly there. It may not be to scale again. I don't want to go with that. I don't want to go with that. But I want to go with this one, 0 pi over 2. When r is 0, it's really the pole. It doesn't matter on pi over 2, so 0. So which means if you follow just those three, that means a graph like this. Okay, just to give you an idea. Okay, and I'm going to erase my work. Now, the next one, so I said the next one, 1/2 is easy also. So I'm going to look for 5 pi over 6 is here. 5 pi over 6 here, and 5 pi over 6 goes for 1/2. So this is 1, so roughly here. Okay, just, Then 1 pi. So I go with pi or 180 degrees. So this one, and just the first circle. Okay. Just to give you an idea right here, everybody. Means go this way in this direction, then come on up in this direction. That's the meaning of it. Okay, for now. Okay, what is easy? So 1 pi. Now I want to go with 1/2 7 pi over 6. I'm going to look at 7 pi over 6 or 210 degrees, and it says 1/2. So this is 1. So 1/2 is somewhere in between. There. Next one is easy. 3 pi over 2 down here. 2, 1 and 2. Okay. This one is good. 11 pi over 6 is good. 3 halves. This is 1. This is 2. So in between. 1 and 2 pi, it's back there. So this is the graph. Let me erase my work, everybody. Put them together. Looks like that. And by the way, you do see the symmetry with respect to the y-axis. All right. We want to graph 1 plus sine theta. Now, I want to graph this slightly different, but flooding points will always work, everybody. And ultimately, you really want to pick a few easy points just to be on the safe side. A different approach for that. R equals 1 plus sine theta in Cartesian coordinates. That means y equals, in essence, you can think of as y equals 1 plus sine x, or y equals 1 plus sine theta. So everybody knows the graph of sine theta looks like this. This is not to scale, right? Okay, so one cycle, one cycle. So if I want, so this is y equals sine x, right? Now, plus 1, that means shifted up by 1 unit. When I shift, and again, take a look at this one is what? Pi over 2, 1, 3 pi over 2, negative 1. So if I shifted up by 1 unit, this becomes pi over 2, pi over 2, 2, and this becomes 3 pi over 2, 0, just to give you an idea. So it becomes, so r equals 1 plus sine theta in Cartesian coordinate from 0 to 2 pi looks like that. So this is, of course, none of them is to scale, but you get the picture. So I'm going to erase my work first. And how do we work on it? Read values of R corresponding to increasing values of theta. As we move with respect to theta, what happens? So stages in sketching the cardioid R equals 1 plus sine theta with this methodology. What do we do? Look at this one. Look at this one. As theta increases from 0 to pi over 2, R increases from 1 to 2. When theta is 0, R is 1. When theta is pi over 2, R is 2. So just to give you an idea as far as, we have the graph here. So when theta is 0, R is 1. When theta is pi over 2, R is 2. That's the first. And so you start from this point, and you end up with this point from 0 to pi over 2, and you just move. Now, what happens from pi over 2 to pi? Now, from pi over 2 to pi, as we are here, then this height goes down to this height, meaning, let me just erase my work. When theta is pi over 2, again, you can plug it in here. Sine of pi over 2, 1 and 1 is 2. But when it becomes pi, this goes to 0, so it's 1. In other words, at pi over 2, we are here. At pi, we are here. So it moves like that. Now, as theta increases from pi to 3 pi over 2, so now this portion r goes from 1 to 0. In other words, when theta is pi, r is 1. When theta is 3 pi over 2, r is 0, meaning it moves there. You see that? Finally, as theta increases from 3 pi over 2 to 2 pi, r increases from 0 to 1. In other words, if theta is 3 pi over 2, r is 0. So this one, everybody, we are here. This one at 2 pi, we are here, so we're moving this way. That's the final answer. Again, let me erase my work.